Hi, Tim. How you doing today?
Hey, how are you, Sanjay?
All right. So great to have you with us.
Yeah.
Let's get started. What are we going to talk about?
Cool. So I'm a program manager on the Cosmos DB engineering team. We're going to cover pricing today in Cosmos DB. So first thing we'll do is we'll just introduce how pricing works in Cosmos DB and how it's a little different than a lot of other databases out there.
And pricing is important.
It's very important, right? And we'll talk about a lot of the technical components as well and really focus in on what request units are and why they're really important to understand. And also, obviously, focusing on ways to reduce costs and reduce the number of request units.
All right, let's get started.
Yeah. So there's two components of your bill in Azure Cosmos DB: the storage you consume and the throughput that you provision. So in Cosmos DB, we basically just bill you on consumed storage. So it's really simple. If you start out with a database that has 0 GB of data, your bill for storage is essentially 0. And as you add more data in, we just bill you automatically. For most regions, it's 25 cents per gigabyte per month. So as a Cosmos DB developer, you don't even have to think about how much data you're storing at all. Now, request units are a little different. For request units, you provision the number of request units that you want. And Cosmos DB is really cool because it's a highly available service that guarantees that those request units are available with 5 nines of availability. So that means if you provision, let's say, 1 million request units, and you're a big customer on, like, let's say, Black Friday, Cyber Monday kind of thing, this time of year, if you provision 1 million request units, those are guaranteed to you. So we basically set aside that capacity specifically for you, Sanjay,
all right.
For your big retail company. Yes. And those are billed at about 0.8 of a US cent per hour for most Azure regions.
Okay.
Now, with request units, you're billed on what you provision. So just like with any other database, it's important to scale it appropriately, right? So you want to ensure, to get good value out of Cosmos DB, that you have the right amount of request units provisioned.
So what is a request unit?
Yeah, absolutely. That's a really great question. Request units are basically a rate-based currency to do reads and writes and queries and things like that. So a lot of databases, if you were, let's say, hosting a database on a VM, there'd be many different bottlenecks to worry about.
Yeah.
Memory, CPU, IOPS. Like, these could all be the bottlenecks as you're doing many reads and writes to your database. And if, let's say, you own a big retail company or a big company on Black Friday, Cyber Monday, if any of these are the bottlenecks, you're going to have, like, performance issues, right? You're going to really need to worry about scaling easily. Now, with Cosmos DB, we have one unit that basically abstracts all of this, and that's request units.
Okay, that's good.
You want to think of them as basically a currency that you can use for database operations. So let's say you have a write, and a write takes 10 request units or 10 RUs, and you need to do that write 10 times. How many request units do you think you need?
100.
100, right? 10 times 10. So really simple math, really simple concept, and really easy to plan and understand when you use them.
I see. Okay. So what about, can't we manage all this automatically?
Yeah, absolutely. So obviously, you do have the option to manually modify request units whenever you'd like. I'm going to go back here. Jump to a quick demo I have to highlight that.
All right. You want to show how to use in action?
Absolutely. So here I've created a Cosmos DB container that has nutrition data, and I provisioned 400 RUs. So as Andrew showed earlier, if I wanted to, let's say, scale up to 10,000 RUs, I can do that really easily, and the change is instant, right? Super fast. But you might not want to even have to worry about this, right? You might want it basically managed automatically by the service. Another good option you have is create a container with a new feature we have called Autopilot.
Autopilot?
Autopilot. So I'll name this new container, just partition it on ID, and come down here. And right now, by default, we're still picking the manual setting, but if I come over to Autopilot, I can choose a maximum number of RUs that I want to scale to.
Yes.
So I'll just pick 4,000. And essentially, I'll scale between this maximum number of RUs and 10% of the value. So I'll scale between 400 and 4,000 RUs. Cosmos DB will manage this automatically. And as a developer, you actually don't really have to explicitly think about scale, which is pretty cool.
So this feature is now available.
Yes, it's in a preview right now. We announced the preview at Ignite.
Okay.
So awesome way to have RUs basically managed automatically for you.
I see.
Now, we also have newly available an awesome calculator for estimating capacity. So if you don't want to have to think about capacity, that Autopilot feature is really awesome. But if you do want to get a sense of capacity, RU needs, and costs in advance, this calculator is pretty cool.
I see.
So we're going to walk through a quick kind of sample together and mess with the calculator a little bit to see how different factors affect the total cost. So I just have a sample Cosmos DB collection in let's say, one region with our SQL API, our core API. To keep it simple, I'm going to turn off multi-region writes. If I were to turn it on, and you have multi-regions or multi-region writes, keep in mind multi-region writes are billed at a higher rate for RUs. And then when you add Cosmos DB to multiple regions, we store a full copy of your data in each region. So it basically should be increasing the total amount of storage in RUs. But to keep it simple, we'll just do one region. Keep session consistency at default. We'll leave indexing at automatic, so just by default indexing every property. And let's say we have 100 gigabytes of data, so reasonably small workload. We can specify the document size. So in Cosmos DB, your data is modeled in JSON. Of course. What size do you think we should specify here? You could pick any number you like.
100.
100 kilobytes? OK, so that's actually a pretty big JSON document. So I'll dial it up to 100, which is pretty big. In general, best practice for NoSQL databases is to keep your JSON documents small.
OK, 50.
So if it's ever possible, we'll check the big one, and then we'll check a smaller one to see what impacts the charge. So in a NoSQL database, if you have really large documents, the cost for doing writes is going to be much higher, right? It's a bigger amount of data, more properties to index, that kind of thing. So the pattern we recommend is if you have things like images, really big parts of data, giant arrays, you want to store the metadata in Cosmos DB to go and search on, and then store like the big parts of the document that are storing a lot of data, like images, for example, videos. Store that in Azure Blob Storage, and then link to it.
I see.
So with this scenario, let's say we do 1,000 reads per second, 300 writes per second, and we go and calculate the cost. The cost is actually going to be pretty high for this small workload if we have 100 kilobyte documents. That's about $14,000 US, and we need to do those writes about 16,000 RUs. Now I'm going to dial it back down to pretty small size, pretty small 1 KB documents.
Real world scenario.
Recompute the cost, and this is realistically what customers would have. In NoSQL databases, small documents are going to give you great performance. And of course, the cost is really economical. And if I were to, let's say, scale up to 10,000 reads per second and 3,000 writes per second, even scaling up by this great a number, the cost for Cosmos DB is still very economical and great value if you're doing a lot of reads and writes against your data.
That makes sense. Awesome. So what if I provision too many RUs?
So if you provision too many RUs, and before I talk about that, I want to talk about queries in Cosmos DB and how you can estimate the cost for that. So of course, with this demo, I basically was just showing simple reads and writes. The idea here is if you had something more complex than that, if you had like a complex query that you had to go run against your data, you'd want to actually go run that sample request instead of using the calculator. So the calculator is designed to be simple, right? Easy to use. But if you really want to get a precise estimate of costs, I'd actually recommend going in the Azure portal, running sample queries, and going and figuring out the RU charge for them. And in Cosmos DB, we make the guarantee that if you run the same query multiple times against the same data, the RU charge is always going to be the same. So if I just list out here that I'm doing these top 3 queries, 10,000 sample writes, list out the number of RUs per second, I can quickly kind of do some math to figure out an approximation of the number of total RUs that I need.
Makes sense.
If I come to the Azure portal, it's actually incredibly easy to figure out the RU charge for a query. If I just add a new SQL query here, I can quickly go and observe the total request charge and see that this one is 47 RU. So that math is really simple. But to answer your previous question, how do you know if you have the right number of request units provisioned, right? It's a very important question to understand. You can come to metrics. So if you scroll down here to the metrics blade of the Azure portal, come to the throughput section, you can actually view the number of requests sent to your Cosmos DB container, and also ultimately view how many request units you were consuming. So if you're using the Autopilot feature, we'll scale up and down based on what you're consuming. If you're not using the Autopilot feature and you're manually scaling throughput, either programmatically or through the portal, this is a great place to go to look at how much throughput you're ultimately utilizing in your Cosmos DB
Fantastic.
container.
Any closing thoughts?
Yeah, Cosmos DB is great value for doing reads and writes, and it's really priced optimally for really request-heavy workloads. So workloads that have a ton of requests, but don't necessarily have amount of data, have a lot of data, these are great fits for Cosmos DB.
Thank you so much for your time today, Tim.
Absolutely. Thanks, Sanjay.
Thanks for watching this short Azure Readiness video.